Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the problem solving session called the circular array rotation. And for this particular challenge, it says John Watson knows of an operation called the right circular rotation on an array of integers. One rotation operation moves the last array element to the first position and shifts all remaining elements right one. To test Sherlock's abilities, Watson provides Sherlock with an array of integers. Sherlock is to perform the rotation operation of a number of times, then determine if the value of the element at a given position. For each array, perform a number of right circular rotations and return the values of the elements at the given indices. And for the example right here, we have the array of a of the parameter a, and it consists of 3, 4 and 5 respectively. And for this k right here, which is the number of rotation, number shift from the original location, is by 2 steps. And the queries it is in the form of array, but it has the consisting of the value of 1 and 2 respectively. And here k is the number of rotations on a, and queries holds the list of indices to report. First we perform the 2 rotations from the composition of the 3, 4, 5, and then the next one should be 3 will be placed from the first to the middle part, and 5 is placed from the last part to the back to the middle part, not middle part but to the 5 to the first part or the first position. And lastly, the middle one, which is the 4, is placed on the right side, and since it is transformed 2 times by rotating by 2 steps, then 4 is going to be placed. The first is from the middle to the right and then goes back up again to the left side or the first position. And on the 5, we shifted 2 times, 5, and then going back to the left one and then back to the middle one. And for the 3 right here, from the first index, we are moving the 3 from the first index to the last index because it moves 2 times, 1, 2, and we got 3 on the last position. And now return the values from the 0 base indices 1 and 2 as indicated in the queries array. And if you're still confused about the first 2 rotations, what it means, like let's imagine if we have some kind of let's say a clock. Oops, let me use the red color instead. Let's say we have a clock and we have 3, 4 and then 5, and we move the clock clockwise, not the counterclockwise, so it moves from left to the right. So if it's only the first step, so 5 will be placed on the 3 will be placed on the 4, and 4 will be placed on the 5 respectively. But if it's 2 rotations, then 5 is going 2 steps and it will replaces the position of 4, and 4 will replaces the position of 3, and also the 3 will replaces the position of 5 respectively. So that is the rough visualization. And now return the values from the 0 base indices 1 and 2 from the queries array indicated in the queries array. And we have a of the first index, which is 1, contains the value of 1, which is 5. Why it's showing 5 instead of 4 is because we are transforming the a array first by 2 steps to the right, and then we have the new index of 1, since the index of 1 is currently on 5, which is the final position, and we insert the 5 into our answer as the number array right here, expected number array. And if you notice, I'm using the TypeScript as our language. If you want to use something else other than TypeScript, then go ahead and encourage you to do so. And we have the a of the second index, which is on the second index we have the index 1 right here with the value of 2. Since it is pointing to the index 1 with the value of 2, then it is pointing to the index 2 based on the value from the queries right here, not based on the index of the queries, but by the value of the index 1 of the queries right here. since index 2 is pointing to the transfer 1, then it's pointing to the last index, which is 3 right here, and 3 will be returned as the new queries array from the queries pointer right here, index pointer, and we will return it as data type of array of numbers. And we have the function of the circular array rotation right here, takes 3 parameters, which is a, k, and the queries. K is the number of rotations, and the queries is the number array based on the example right here, and the a itself, which is the array that needs to be rotated based on the k number, or the number of rotation. And without further ado, let's do this by creating the length of the array. We need to determine the length of the array, called the constant length of the array, represented by the n, and then we need to declare the length of the array using the a.length, and we get the length of the array. And the next one, we need to mutate the k with the k using the remainder operator, and then using the n. Why we should do this is because we are going to do the right rotation, shift it to the right. If it is already on the right side, it will be reset to the left side again. So let's say we have the number of k, number of rotation of 2, and we need to modulo this, not modulo, but remainder operator using the n, the length, since n is the length of the a, then we need to use the 3 as the length, and we got the remainder of 1. So that way if we happen to find this, what is going to place on the 4, which is 4 is the last place, then 4 is going to be placed on the first place, or the left side. Then it is shifted from the counterclockwise, which is only 1 right here, and also 5 right here. We got this from the first position, and we got the 5 as the middle position. Let's say if we have the number of k rotation, which is 3, but then the length of the array, which is also 3, then we got 0. And why it should be 0, the k value should be 0, it's going to be like we need to like some kind of shortcut. If the k number is higher than the number of the array of the a, then we need to normalize this. Let's say if it is 3 rotations, but then the elements, we only have 3 elements, then it is not going to move anywhere. Let's say we have the array of 0, 1, and 2. If we have to move 0 by 3 times, let's say we only have 3 elements, then we move this 1, 2, and then 3. We go back to the position 0, or the initial position that we already started. From the position 1, it's also the same thing, also applies on the position 1 and also position 2 right here. If we happen to move this 3 times, 1, 2, 3, and we still got the same position, just like from the beginning. The same thing also applies on the k number of 6 or 9, or even 30. You might want to count this like 30 times, and we still going back to the initial position because the number of elements is already as the same 3, as the same value, and the same amount is 3 right here. So we don't have to put more effort than this one. So this is a more simplified way to calculate the array, so it's like a shortcut. And the next one is going to be, we are going to create a constant variable called the array copy, and we take this as the empty array. And next one, we need to iterate over the a array using the for loop for let I is equals to 0 as long as I is below the n. Since n, we already declare n as the length of the array, of the a array, then we can use the n, we can utilize this, the n, as the array.length, and it's more readable. And the next thing, we need to do the array copy .push. We need to push the array using the value from based on the index that we already rotate by how many times from the k rotation, from the initial state, from the a right here, a parameter, to the last from the number of rotations from the k to the right or clockwise. We can do this by passing the k, not k but a as the parameter, with the index noted by the square brackets, and we need to determine the index by using the I minus the k and then plus n. Why we should use the I minus k is because we need to track. We don't have to use the array method to mutate the array one by one as we move this to the right or rotate the array composition to the right. We can just directly assign the last state of the array based on the index and based on the number of k with already normalized from the beginning right here, and the number of the length of the array. Why using the subtraction? It's because we need to use this, calculate this backwards. It is determined by the current index of the for loop iteration. We need to determine the index 0, and index 0 minus the k, number of k. If it is k is 2, then it will be, the result will be minus 1, but then we don't have minus 1 as our index. It will point to the weird position of the index, and it is not the desired position that we want. Then of course we need to normalize this by using the plus sign, using the n to prevent the negative numbers. Is because we are counting this backwards. Let's say we need to find the 4, then we need to use a backwards number of the index right here. We need to find the last position of 4 right here. How do we do this? How do we determine the value of 4 right here is placed on this exact position of the index 0? It is by using or turning back the time or the sequence from the counterclockwise, from the left to the left, I mean 1 and then 2 times. So this is the supposed position or the initial position of the 4. If you look over this, from the initial position 4 is placed on the middle part, and also the same thing on the 5 right here, which is on the middle part. Where is the initial position of the 5? We count this 1 and then 2 times the middle part, left part, and then going back to the right part by counterclockwise, and we got the initial position of 5, which is placed on the last index. And the last thing that we need to do in order to make this not out of bound again or outside of the determined index, predetermined index, that to prevent this from going out of index 0, 1, and 2, if we only have 3 elements of the n right here, then we can use another modulo or the remainder operator, using the remainder operator of the n. But then we need to wrap the I, k, and n first, and then lastly we use the remainder operator from the left hand to the right hand operator using the n right here. And lastly, we need to declare another array to assign this from the queries array from the index 1 and 2, and transform this using the 5 and 3 respectively, because these queries of the index 1 right here is pointing to the 5, and the index 1 right here, which is on the value 2, which is pointing to the index 2 of the 3 right here. We can use the traditional approach by using the constant, just like on the above codes. In the constant queries array, and we declare the empty array, and then we can use the for loop for let I is equals to 0 as long as I is below the queries dot length, and then I plus plus. Why queries dot length? Is because we are iterating the queries array, no longer iterating the A array, because we already completed. And we need to assign the queries array.push. We need to push the queries array from the queries in the queries of the index, but then we need to wrap this, because we are using the transform array of the array copy right here from the last state of after all of the rotations. We need to use the array copy instead. How is we can use this by declaring square brackets, wrap this in the square brackets, and then in front of the square brackets we can use the array copy, and then we can finally return our queries array as our answer. So let's run this to see if it works. And we have all succeeded code. But let me tell you one more thing, one more approach. Instead of using the queries array, declaring another empty array and using the Array.push, and by declaring the for loop and then finally we return the queries array, we can use the far more simpler approach by using we can eliminate this part or commenting this part, and we can use the queries.map using the map function, and that way we are mapping the value from each element based on the index that already pointed from the value of the each queries array based on the index from the new array copy that already created from the last state right here by using the queries map. And then for each value we can use the arrow sign, arrow function, and we implicitly return the array copy as the element using the index of the value, and that way we are utilizing the each value of the queries.map, iterating over the queries.map value of 1 right here, and we utilize the value of 1 based on the array copy right here, and we use the implicit return without using the return statement and the curly brackets, and we can just return this directly. So let's submit the code again to see if it works. Its type cannot be determined is because we are using the TypeScript as our language. We can use this declaring a type from the array copy by using the number of the number array right here. That way we're explicitly declaring the type of the array copy variable right here as the number array or the array of integers. Let's submit the code again to see if it works. And there you have it. And from the queries map, let me explain this again. Queries map, it is the same thing as the queries. We have the queries variable or the parameter right here, queries. We have the value of 1 and 2. If we happen to use the returning the queries.map, we are basically creating a new shallow copy of the array of the queries, which is only 1 and 2. But then we convert this as I'm using the thin arrow to determine the transformation. We are using the 1 as the index of the array copy.value. Array copy using the index from the 1 right here. Array copy of the index 1, we got the value of 5. And the next one, we use the 2 as the index, and we got the array copy of the value index, we got the 3. Let's say if the queries is the only 0 and 2, then the result will be 0 and 2. Since queries.map is using the shallow copy as the method, and we returning the 4 and 3 respectively. So that is the explanation of the queries.map. So that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.